Let's see how to graph this function y equals 4 times sine 2x minus pi. We want to show at least one period. In order to make our life easier, we do not consider this 4. We just consider this one, sine 2x minus pi. We know this 4 is going to change the amplitude in the vertical direction. So we know the amplitude for this function is just 1. So between here, this function 4 with coefficient in front of sine, and this function, that's an easy way to go. Easy to understand. Now, we'll first work on that. Well, sine x has like 5 key values. 0, x is 0, you have a 0. So x is pi over 2, you have a 1. And then you have a 1, 2, 3, 4, 5 points. That's basically right here. 1, 2, 3, 4, 5 points. We will see how these 5 key points is going to change if we are given a function like this, sine 2x minus pi, like this. We should have the same y value, 0, 1, 0, negative 1, 0. And then for sine x, we just need those 5 different x. Well, for sine, here is 2x minus pi. In order to have a 2x minus pi be 0, pi over 2, pi, 3 pi over 2, and 2 pi, we want to see how we need to require x behave. We know if 2x minus pi is 0, then we set up 2x minus pi is 0. We add pi on both sides. It gives us 2x equals pi divided by 2 on both sides. X is pi over 2. So in order to have a big quantity, 2x minus pi is 0 here. Then we do need x is pi over 2. That's indeed true. If we plug in pi over 2 here, 2 times pi over 2 is pi, minus pi is 0. So indeed, if we let x is pi over 2, we have the whole quantity 2x minus pi is 0, then sine 0 is 0. So basically the point right here, 0, 0, goes to pi over 2, 0. So that's what it meant. You may consider pi over 2, pi, 3 pi over 2, like pi over 2, pi, 3 pi over 2, and then 2 pi. Those for the rest of the 4 values, and how we are going to require x. Let's choose the last point. If we required 2x minus pi be 2 pi, we can set up this equation. Plus pi on both sides, then negative positive pi cancelled. We have a 2 pi plus pi is 3 pi. Left-hand side is 2x. Divided by 2 on both sides, we required x equals 3 pi over 2. So, in order to have a 2x minus pi be 2 pi, we required 3 pi over 2. X needs to be 3 pi over 2. That basically says that previously we have a 2 pi 0, 2 pi 0. Now we required x is 3 pi over 2. Then we plug in here. We should have a 2 pi. You see 3 pi over 2, you plug in here. 2 times 3 pi over 2, you have a 3 pi. Minus pi, you have a 2 pi. Then the big quantity 2x minus pi is 2 pi. Then sine 2 pi will be 0. So basically, you have a 2 pi 0 previously for this point. Now it has to be 3 pi over 2, this point. This point right here. You can check the middle 1, 2, 3 points, and then how this is going to require x needs to be in where. The rest of the 4 you may do enjoy yourself. You will know origin 0, 0 is going to switch to this place, and 2 pi 0 is going to be right here. Correspondingly, pi over 2, 1, 0 pi, pi 0, 3 pi over 2, that's correspondingly those 3 values will change accordingly. One will be here, another one will be here, and another one will be here. So basically this one period from 0 to 2 pi comes to be pi over 2 to 3 pi over 2. Okay, what does this mean? It means previously one period from 0 to 2 pi, now it only goes like pi over 2 to 3 pi over 2. What's the distance? Pi over 2, 3 pi over 2. 3 pi over 2 minus pi over 2 is pi. So this function completes one period just in pi this length. You see here is pi over 2, here is pi over 2, then add together is pi, and in between is pi. So basically, the period for sine 2x minus pi, the period changes from 2 pi to pi. So these two still plays the rule is what? Is previous formula 2 pi divided by 2, which is pi. So in order to make the connection between the given function and this one, we pull the 2 out, and then inside is going to be x minus pi over 2, because you distribute these 2 to the 2 quantities inside the parentheses. 2 times x is 2x, 2 times pi over 2 negative is pi. So you can change this one to this one. Okay, and then you can see this function, the period is changed. You can use this formula to get pi, and you can see the function is shifted from origin to pi over 2. So you want to do is change this form to this one. And then here you'll get this picture. This is like one period analysis. If we do not do the one period, the whole thing will be like this. will be like this. That will be the graph for sine 2x minus pi without considering, the period change from the range change from 0 to 2 pi. It goes to those pi over 2 to 3 pi over 2. This is one period change. Okay, let's temporarily forget about sine. Okay, this is the picture, final picture we get for this one without consider one period. Okay, so actually, then you may wondering what's the relationship between sine 2x and this one. Sine 2x is the one right here. How to get the picture from sine 2x to sine 2x minus pi? Actually, you can see right here, if we forget about this one period, we just consider sine 2x. Looks like if you have a sine 2x, you simply flip sine 2x, you put negative in front of it. You'll get this one, which is identical to this one. So that's why, sine 2x minus pi equals negative sine 2x. We can get rid of this negative pi by just simply put a negative in front of sine x. So indeed, this is the identity. That's the side product. Y equals sine 2x minus pi is negative sine x. Okay, you actually proved by doing the picture. Now, that's one thing we want to point out. Another thing is that if you want to get from sine x to sine 2x minus pi, what is the middle step? You first want to do is get this one and then shrink, compress the picture, or change the period from 2 pi to just pi, because period for this one is pi. Okay, now here is 2x. If we have a one period, it will be like this. It will be like this. So we may forget about all periods. We just think about this one. So from this picture to this picture, that's one period right here. And then in order to get the one right here, that's the one, we had at the very beginning. So first you do is compress the picture from 2 pi to pi. And then you do the shifting. This point goes here, and this point goes here, and this point goes here. Okay, so then eventually you will have the picture for the one right here. Okay, so what is the middle step? Algebraically, in conclusion, you change this picture to the one right here. Then you want to have the picture for sine 2x. You want to have this picture, and this is one period. You want to have this one. And then that's the step 1. Change the period from 2 pi to pi. You get this one first. And then shift this picture by pi over 2 units to the right. Subtraction. You'll get this one. Okay. This is like one period analysis. And then you know the whole period will be like this. The whole period for this red one is actually like this. So, okay. So one more time. From sine x to the picture right here, you want to find out this one first. And then shift this picture pi over 2 units to the right. You will have this one. Okay, this one. And then you know the whole picture will be like this. All right? Okay, I'll see you next time.